You are welcome back to our channel, and in today's session we are going to be looking at database architecture. You remember in our previous session we introduced database system, and today we are delving into database architecture. In today's session we are having the following objectives: that's understanding the fundamental principles of database system, as well as exploring the various architectures such as centralized, client-server, distributed, and then parallel system. Also, we are going to analyze the key concepts such as transaction management, data storage, and system optimization. And we are going to wrap it up by having a knowledge in designing and implementing efficient database architecture, so that at the end of this session, students out there will be able to explain the component and the architecture of the database system itself. We'll also be able to differentiate between centralized, client server, and then distributed system, as well as applying the concept of this transactional management and concurrency control in their day-to-day architectural design of the database. Also, we are going to evaluate the performance factors in parallel and then distributed system by developing a practical skills for database design and optimization. Introduction. We know the structure or the structural design and methodology of our database design is what all database architecture is, and these form the core of a database management system. That is the architecture which is going to dictate how to store in, organize, and then retrieve the data that you are manipulating in on the database, which play a very crucial role in the efficiency and effectiveness of database management. We have database architecture as the topic of the day. Let's look at what this database architecture is. So we know database architecture, or we take it from the architecture itself. We know we have architect as a course or architecture as a course. These deal with the conceptual designs of our models. So remember, we are dealing with database here. It means we are going to have the conceptual design of these databases. That's what all this database architecture is all about. And this is going to represent the design of a database management system, which helps or which assists in designing, developing, and then maintaining the database themselves, ranging from coming up to design as a database designer or a developer, coming back to develop, that is to implement those architectural designs you have laid down on a pictorial representation, to the maintainability you have implemented. Then you need to follow up and see how these databases works. So, and also this a well-structured database, if it is a well-structured database, can allow the dividing of the components. That is, if it is a well-structured, you can be able to divide or group these components of the database, which can be independently be changed, modified, or we can say it replaced in the course of designing, in the course of implementing, and as well as in the course of maintainability or maintaining the databases. So also, this database architecture, it also assists the designers or developers in understanding the key components of the databases. The key component, while you are designing the database, there should be a key component in that databases. So it's only your database architecture allows you to have a familiarized understanding between these components. That's the key component of these with the designer. So that this database stores very critical information if the need arises, and also accessing the database quickly and then securely. So this is all what we need about the database. If we cannot be able to access our data very quickly, or we cannot securely access our data or retrieve our data or store our data in the database. So it means the aim of having databases is defeated. Therefore, selecting the very correct architecture of database management systems helps the developer for easy and efficient data management. Whenever you have a database architecture on ground, it means you can be able to correctly select the architecture or these key components that can assist you in managing and then efficiently transacting with your data. So we have some of the key characteristics of these database architectures, and what are these key components or key characteristics of this database architecture. Let's look at them. One, we said these are database architecture assist the efficient data management. So that's to say management of data or data management should exist within the database architecture, ensuring also data security and then data integrity is of very essential. And then you should be able to also enhance system scalability and then flexibility. The system should be able to function at any other system, and also should also be able to be very flexible for users to make changes or modify it or replace any component within these databases. That's what we have as the key characteristics of this database architecture. So this database architecture is further been classified or divided into three architects, and we regard it as types of database management system architecture. So mainly we said they have been grouped or categorized into three. One, we have what we call one-tier database architecture. Two, we have two-tier architecture, and then we have three-tier architecture. But in some scholars, you can see they will be having a hybrid tier architecture. So, but that is not what we are going to concentrate on. We are going to concentrate on this very three-tier architecture. No, nevertheless, the hybrid tier architecture is those the comprises of of one or two of these database tier architecture. That is a combination of a single tier architecture, which is one, and then with the two tier architecture, or the one tier architecture with the three, or the three tier architecture with the two, or the three tier architecture with the one tier architecture. So that's what will give you a hybrid tier architecture. So let's look at this one tier architecture, which is regarded to as two tier architecture. Oh, sorry, it's regarded to as a single tier architecture in database management system. This is the most simplest types of data architecture or database architecture we have in place, in which the client, the server, and the database all together are going to be reside on a particular system. Are we together? The client, the server, and the database. We have three components of the database here, right? The client, the database, and the server, they are all going to reside in a single system or a single machine. This to say that you have a system. We can just take a typical scenario like we are practicing a web development, where we use a WAMP or a XAMPP as our server. And this our system should be our server machine. Our database lies within this WAMP or XAMPP. And then the application we are trying to develop, or we developed and then test running it on our particular system, we call those as what? As a client. So all together of these three are going to be reside on a particular machine. So that's what we regard to as a single tier architecture or a one tier architecture. We said also by this a simple one tier architecture example would be anytime you install a database in your system and access to a particular SQL, that is structured query language, but such architecture is rarely used in production. So this is all about what we have just bear in mind the three components of the databases are all reside on a particular machine. You are done with that single database architecture. So, and this one tier architecture, we also say it is the most commonly used data architecture in place. They are very small scale applications, and the database learning process are easily in terms of installing the database locally. So we have advantages of these single uh, single tier architecture. One of the advantages is that they are very easy to install and maintain because they have been reside in one single machine. Two, they are what? They are cost effective for personal use. So you will not spend a lot of money in what? In having those databases in place. And then the disadvantages to this database architecture is that they are not suitable for multiple user environment. They are not what? They are not that suitable. You can testify you have all done web design application. So it is very difficult for one to share a database that is housed locally within that your WAMP or server. So they are not that very effective, and then they are not suitable for multi-user. And then scalability is very, very limited. So we have what we call as what? As our two-tier architecture. In the two-tier architecture, we have what we call, or we can say this is the birth. This tier architecture is based on a client-server architecture. That is an improved version of a what? Of a single tier architecture. And it's like what? The client server application are what? Are going to what? Be communicated directly, or are going to what? Communicate with the server directly. So this is also based on what? Based on a client-server architecture where direct communication take place between the client and the server without any intermediaries. That is, there is no agent in doing that. They are communicating directly. So the client now are going to send requests, just as you can see on what? On your screen there. The client application are sending their requests directly to the databases, as well as getting the response directly what? Back to the client. So this is suitable for small, medium enterprises where you can be able to have your what? Your databases on a central computer, and then later in time you distribute what? You have a shared group where each and every client within that very enterprise or that small group or work group can be able to access a database located on a terminal named as a what? As a server. So we have our components here. The components are two. That is components in database in two-tier architecture. One is the what? Is the client tier, which is the client application, and this handles the user interfaces and then the request data from what? From the server. Whenever you are sending requests, you are sending it through these user interfaces, and it is what? Going to what? Transform to what? Or being transferred to a data server. So the second one, we have what we call data tier. So in data tier here, the data tier here is what? Is what we call as our databases. So this what it does is going to what? Process and then store the data you are sending to the database. That's what it does. Are we together? So the advantages now, the advantages to this two-tier architecture is that they are easy to maintain and modify. They are very, very easy to maintain and modify, and they are very fast in communication, in sending communication between the client and its server. Whenever you want to send for communication, so the transmission is very seamless. So disadvantage of this two-tier architecture is that the performance degradation. So you need to what? To degrade the performance, and with what? With multiple concurrency users. So once you are having a number of users increasing to the system, it means your system will be what? Will be degraded in terms of what? In terms of processing. So there is a what? A low in processing during your what? Two-tier architecture. So, and no cost effective for a large enterprise. So that is what? That is a disadvantage of this. So we have also we have mentioned advantages. So we have three-tier architecture. In three-tier architecture, these are typically comprises of the presentation tier, which is called also a client server, and then we have a business, or what we call as data access tier. Are we together? the data access tier, and a data tier. That's the three layer in the three data or in a three tier architecture. We have them as the client layer, that is the presentation layer. We have them as the business layer, which is also known as the what? The logical layer, and we have them as a data layer, which is also called databases. Let's look at these one after the other. When we talk about a client layer, this in essence, we are talking about how to handle user interactions. Are we together? How to handle user interactions like forms, like input, output, that is IOS. So, this contains user interface part where you can be able to send or transmit your data from from this client server to to a data layer. This layer is used for the for only the design purpose, where data is represented to the user, or for data to be imputed or to be keyed in essence, is just a designing a registration form which is going to contain a text box, a label, a button, just the normal commands that we usually issue during our interaction while we are doing course registration, while we are applying for JAM, while we are applying for Pursue TME and the rest. So that very particular user, that very particular UI you are seeing, that is user interfaces that you are interacting with, is only familiarized to you alone. You don't know what is taking place at the business layer, that is the logical layer. All you are doing is that you want to submit your data, right? You want to impute and submit. You don't know what is taking place at the logical layer. That is your client layer. So if we talked about the business layer, this we are talking about about all business logic that we have that have been written, like the validation of data, the calculations of data, the insertion, and the rest. And here, what we are talking about, this validation, we have form validation in PHP. Whereas if you did your form, assuming you want to only collect email address, for you to validate this, you must have something like a format or a syntax that particular field, if and only if it's going to accept data from the user via that very field, it should be able to contain anything with @sign. That is, should be a name @domain. So it doesn't care whether that domain is a Gmail or Yahoo, Hotmail or whatsoever. The domain can be your personal emails. We all have institutional mails, and this domain can be as that your institution, like your name, then at your domain name. So anything regarding that, you can be able to use in validating that very particular email field. And also, if you can also validate by using maybe order name. If you are accepting order name, we can say that order name you are about to accept can be order name with can be able to accept data with a null or not null, is also part of part of validation. So this is also part of of validating your data. I hope we are moving together, so none is left behind. So when we talked about data layer, here we are talking about the database, and also while talking about the database, we are talking about how we can be able to handle data storage, how we will be able to handle data storage, and then we retrieve operations. This is where we said we have the back end, right? So in this is the actual database that comes in a picture. So you can be able to have what we call data access layer, and they are going to contain method to connect with the data basis or database, and also to perform what we call queued. You can be able to create, or we can say it, insert, update, delete, and then get data. That is what we call IH. That is insert, update, delete, and then get. We can also call it crude. That is create. That is you are inserting now. You are creating as well as inserting. So that's the order name. And we also call read. That is you retrieve or you read from the system. And also we have what we call update. You modify. Then we have what we call delete. So all these are going to take place at at a data layer, that is the database, or sometimes call it data access layer. So let's look at the advantage of these layers. We have, or the tree type architecture, we have it is very scalable. There is a scalability. It means that each layer can be able to scale independently. You can be able to choose each architecture independently without having them together. That is one. So it also improve security. That is, your database architecture will be able to enhance security. Clients do not have direct access to the database. That is the main security there. Client is only dealing with the interfaces and sending it via our business or logical layer. So once it's sent, it's the duty of the logical or the business layer to see how it can be able to pick up those inputs and then translate them to what, just as the way we are having in our programming, right? Once you write a code, interpreters will come in and fetch in these data in order to interpret or translate them into what, a machine understandable languages, that is in form of ones and zeros. So the same thing what we are having here, please. So another advantage is improve performance through through caching and then optimize data flow. So, and they are very easy to maintain, and then you can be able to extend it without affecting other modules. So what is saying here, in essence, you have a database with 3 tables. You have created such databases and you want to modify, like you want to add another table. So without affecting these 3 tables, you can be able to add, to insert a table into that databases, again making it to be 4 from what, from 3. That's what is saying here. So the disadvantages is with data architectures are what, they are very complex in designing and then deployment, and they are highly initial development cost. So whenever you want to take on it, so the initial cost is very costly. So also we have advantages of multi-tier architectures, and they are very, we can say it's almost the same: increased performance, flexibility, and what have you. So what are the challenges now? What are the challenges? We have this: improve in data integrity, improve security, easy to maintain, integrated architecture, application performance is good. Then we have them. So also, what are the challenges now associated with this uh, database management system architecture? What are the challenges? So we need to look at these challenges. Despite the benefit we are having in database management system architecture, also we have several challenges that lies on this. And the challenges is what? Data integrity. That is ensuring consistency across multiple tier or multiple tiers is what? Is very challenging in dealing with your database. So complex development. While you're doing complex development here, you need to be what? Very careful in terms of what? Planning and the resources allocation. You cannot just say that you're taking part of database architecture without looking at the what? At the cost or the planning resources that you are going to allocate to each of these databases. So you must consider the plans and then the resource allocation. So network dependency is also of challenge. So because your performance of this database relies solely on network effectiveness. So in doing this also, you need to make sure that you are having a very reliable and very stable network connection for you to be able to have an effective connection between your client and the data layer architecture. If we talk about cost, this is where the problem lies. So the challenge in cost is just we can say is just huge. So implementation and maintaining costs can be very high in what? In multi-tier architecture. So one need to be what? Very careful with this database management system architecture. Also part of this database system architecture, We are having what we call a centralized and a client system. We also have a server system architecture. We have parallel system architecture. We have distributed system, and we have network type. So if we look at the centralized system architecture, this is where you have a database that are what running on a single system, and they do not interact with any other computer system. So those systems are just there, just like the way we said we have single database or single user in terms of operating system classification. We have single user operating systems such as Windows. So it's only one person that can be able to interact and work with this particular database, and only that very database can only be located on that very particular system, and do not allow any access or any external access to the database. So also we said these are our general purpose computers or general purpose databases, and they are one to few CPUs that can be able to have uh, a number of devices that are going to be controllers, or that are going to be controlled by the connection of this database through what we call a common bus. This is the typical operating system scenario, which are going to provide access to a shared memory. If you remember, you are saying 213, which is operating system, very well. So single user system example like the personal computer or a workstation, and the desktop unit. So they are all what form of this centralized system. And if we talk about a multiple user system, are going to have more disks. In terms of multiple user system, you need to provide more disks, more memory, more CPUs, and then multi-user operating systems such as Linux. Are we together? We know Linux support uh, multi-user operating system, right? So that is why in a server system, most of the time they prefer working with Linux or Macs, rather instead of working with Windows. So here we are saying that in these multiple users, you need to improve all these areas in terms of memory, in terms of disks, in terms of CPUs, so that you can have a very large number of users who can be able to connect to the system through this terminal, which we usually call them as a server system. Are we together? So just as we can see here in a central computer system, we are having CPU, we are having disk controller, and the memory is at the bottom. So our disks under disk controller are going to access each other. So the line connecting from the CPU to the graphic adapter is the bus now, and all of this relies on solely on the memory. So also we have peripherals like the mouse, keyboard, printer, monitor. So this mouse, keyboard, printer, we know they are they are supplying input to the user, to the system. So they are dealing directly with the USB controller to the memory, because they are supplying data, they are supplying information to the system. So that is why they are dealing with the USB controller. And with the monitor is the output, and is dealing with only the graphics adapter, right? Because the graphics adapter is responsible for giving back the information you have typed into the system. So assuming you give a command using keyboard, you typed information using you give a command using mouse, you typed information using keyboard. Are we together? Or if you are you are having online printer that is connected to this, right? So all these things are going directly to the memory. So also your monitor, if it's going to retrieve those things, are going to use the visual graphics adapter, or the graphics adapter, in order to give you the output. One can ask, why is it that printer lies on the USB controller, where monitor lies on the graphics adapter, and all of these, they are form of input output units? Yes, the reason is, our monitor and the printer, we know they are both input devices, output devices, sorry. But the issue here, one is giving you a graphics represent. It's not like a form of a hard copy, right? It's giving you a graphics of what you have done, like you want to see it on a screen, a visual representation, right? It's not to say even graphics, a visual graphic representation where you can be able to see it via a screen, just the way I am delivering these lectures now. You can be able to see my slides as through this monitors or through this screen of yours. So all these deal with the what graphics adapter, because graphics adapter on a system is the one that is responsible to give you anything visual output, where printer can be able to give you a printout data or an output data on a paper. Are we together? On a paper, even if it is going to be a visual, it should be a hard visual, please. It's not a soft visual to say. So this is how we have this, and this is the client server, and we can see the system client server here, which is going to satisfy the request generated at M. So at M client, that is, we don't know the number of clients, so as many clients as we have it, and then whose general structure is shown below. If you can see it, we are having a network bus. Straight, we are having a server, so the network is interfacing between the client and the server, just as the way we have in the two-tier architecture. So all the clients are accessing the server through this network. So, and if they are sending information, it first move to the server before to the network before the server, from server to the network, then to the client. So, and this is the client server system also. And in this client server system, we know we have what we call database functionality, which can be divided into two. And the division here, or the categorization, is going to be a back end and then the front end. When we talk about back end, this we're talking about the structure of the database that a client cannot be able to see or interact directly with it, and this manages the access structures. The access structures, like the query evaluation and the optimizations, concurrency control and recovery, they all lies on this backend. So it's only understood by what? By the developer. So, and is going to have a interface in between this backend and the front end through the use of a server. That is it. And this front end, we know, is it consists of a tool such as the form, such as report, and this is something that we have done in this very class while we are dealing with the three-tier architecture. And this, we know, we are going to have all this interaction with the front ends is the UIs, that is user interfaces, and they are going to control when you send it, moves to the back to the server. You remember the database architecture we did in our previous class, where we have a client sending requests through the network. Are we together? Through the network, and this network through the network by the use of SQLs, that is a language. You need to choose a language in between. This client server can be able to communicate with the databases. The databases will be at the end by the also interfacing with database management system. And if a client is sending requests to the database, it means it must first of all be translated by by the SQL, that is structured query languages, right? Since you are not using NoSQLs, right? That is where you are going to use a non-relational databases. But here in this class, remember, we are dealing with relational databases. So that is why we need SQLs. You are sending through the SQL to the applications, or to the application through the SQL, then to the database management system, then to the databases. Are we together? It's too technical, I know, but this is something that we have been doing in many courses of ours or in the field of computing. So this is what we have generally, as you can see on the diagram, or in the diagram below. So we have this is a server system architecture, and in server system architecture, this we know whenever whatever we are sending is going to the server that houses the databases, right? That is it. So, and this server architecture are going to be divided or classified or grouped into two. One, we have transactions server, and one we have data server. The transactional server here are widely used in relational databases system. So whenever we want to use relational databases, we use transactional databases, in which you send, you receive, you send, you receive through the medium of a network and what have you, or through the network and then the SQL and the application. So when we talk about the data server, this uses what we call object-oriented databases, and then here you work with mostly NoSQL. You just interact whenever it's a tree-like structure. When you are dealing with the database, you access it strictly. Sometimes you don't even need. It's a very straightforward language use, English language use databases. Example of such, you can be able to use MongoDB and where you can be able to interact and then see how you can be able to transact with this your data saver. So, and your transactional system also called what we call query system or query server systems or SQL server system, such as the where the client can send requests to the server and can also be able to retrieve that request or get a response from the server, and can also be able to execute at the server. So the transactions are going to be executed by the server and at the server. So the results are going to be chipped back. That is the response, right? The response you are going to get from the directly to the client directly from the server also. So also we call this as what? Remote procedure. That is a remote procedure call. That is whenever you send a request, you can be able to be communicated back. Under remote procedural call also, it allows many of these remote procedure calls to form a transactions. So where you can have an open database connectivity, and this is just like a C language to say. It's like a C language application program interfaces that are going to be standard from Microsoft for connecting to the server. We have SQL, Microsoft server, where you can be able to send through the SQL, you send requests and you retrieve from that. So this is what we have so far in this particular sessions, and we believe what we had in this session is a foundation or fundamental. It's very essential to say. Understanding your various database management system architectures are very paramount in order for you to be able to design a stunning and very robust and efficient database solution. So you need to also understand this database architecture. So also choosing the right database architecture, it depends on just so many factors, such as the scalability, the requirement, the security need, and the performance expectation. So whenever you are designing this, you need to collaborate with your clients. You collaborate with the people you are deploying these databases to, so that you can be able to know the types of requirement, the types of security they need, and the types of performance they want, and at what level do they need probably changes and what have you. So with the knowledge I believe we gained in this from this module, so you can do better in designing and implementing databases that are going to meet our day-to-day demand, that is conceptually, and the future of our database implementation rests on the on the knowledge you are acquiring from your data architecture. So thank you for being part of this class. We appreciate your patience.